Do you know how to do ANOVA analysis of variance in Excel? And do you want to learn how to do it without any dependency of statistics software like Minitab? If yes, then it is very, very easy to do it. And all you need to do is you need to plug the add-ins in Excel and you will get the result. Let's see, we're going to do it ANOVA in Excel with two example. We are going to compare the result in Minitab also as well. Welcome back to Abra Knowledge channel. We are going to discuss this wonderful topic and it will be very, very useful. Please stay tuned till the end. You will get the amazing piece of information. So this is the data set I have, and I'm going to delete all these together and then we can do it one more time. I will demonstrate all these value one more time. And this data set I have already explained in the past video. Using the Minitab, I have already done it. Now I'm going to explain how to do it in Excel, right? To do that in Excel, you need to go to the data menu, and under the data menu, and you have a data analysis. Please note, if you have already added the add-ins, then you'll find it. If not, you will not find it. In the previous video, I have already talked about it, how to add the data analyze pack, right? So all you need to do is you need to go to file and options, and then you have a add-ins, and then this is analyze tool pack, and then have a go, and then you will be able to download it. I have already done it. So right, so it is that's the reason in the data menu it is already showing up. Okay, however, let's see that how we are going to do it. Data analyze, and then you have a lot of options are coming up. So we're going to do it ANOVA single factor. Give okay. And input range, one of the point we noted is if you do it along with the headings, it will not accept. It will show it contains non-numeric data. Let's see that. So this is incorrect method, but I'm going to show that is going to give an error, right? So I'm going to keep it here and you'll find that error now, right? ANOVA single factor input range contain non-numeric data because Kurt, Michael, and Sherry non-numeric, right? So that therefore, all you need to do is you need to select the values as such, only values, right? And give OK. And then output range, I'm going to store the output here in G7. Just give OK. And alpha 0.05, I'm going to keep it. Just give OK, right? Now we have got all this one, and then Kurt, Michael, and Sherry, it has given column 1 and 2. I'm going to replace here, right? I'm going to just keep it here so that it will be easy. So let's see that very important, the values count is 20, sum is this value, and average is done, and this is the average, and this is the variance. And you can also find out the standard deviation. Standard deviation, you all know, square root of variance is the standard deviation, right? So let's see, this is the standard deviation for Kurt, Michael, and Sherry, right? And then we also have got the Anova tab also as well. Anova, you have a between group and within group, and then sum of square degree of freedom. Why degree of freedom is 2? Because 3 people, Kurt, Michael, and Sherry, 3 minus n minus 1, that is 2, right? And then ms, that mean is square, and then f value and p value. This is a p value, the heart of the hypothesis, right? The heart of any hypothesis testing you do, whether it's ANOVA, whether it's a 2 proportion, whether it's a chi-squared for discrete one, for everything, p value is important. And then within the group also you have got. So within the group 57, how it is showing that as a 57, and this has taken the 57 value, and then total degree of freedom, degree of freedom is 59, because we have put together, we have 60 is n, and n minus 1, you will find it 59, right? So let's see. Okay, now in this case, by doing this one, p is greater than 5%. If it is less than 5%, we're going to reject the null hypothesis. If it is greater than 5%, we are not going to reject the null hypothesis. Do not reject the null hypothesis. That means Kurt, Michael, and Sherry are same, right? So that's what we are going to if it is same, like reject, that means reject the null hypothesis, meaning like they are not same. in this case they are same. That is, in the past video I have already talked about how to consider it and all that. Let's see that how to do it in Minitab. We're going to compare the result in Minitab. Go to stat and go to Anova, go to one-way Anova, and then you will have, I have already put like curd all these value. Maybe I'll put it one more time. C2 all the way to C4, select and give OK, and you will get the interaction. This is the interaction we have got it. I'm going to come back later, and then you have here, right, exactly the same value we have got. For example, 2-factor degree of freedom is 2, fine, and more importantly, p value is 92.3, exactly the same value we have got. If you just have the only 3 decimal place, you will find the same value, exactly the same value, and f value 0.08, and exactly the same. Mean square you will have, right, exactly the same value. Degree of freedom is 2, exactly the same value, right? And then you also have this mean value also as well. See, 20, in all the cases we have got 20, and then you also have got the mean, exactly the same. Here it says average, right, 1001 and 1.01, the same value we have got. Standard deviation 0.39, 0.37, 0.37, and here also you've got the same value as such, right? You can do it directly in Excel itself. So let's take another example. Another example, this also I have done in the past, the same example using Minitab alone. Now we are going to do it in Excel. In this particular case, so if the value is like this, we'll not be able to do it, but there is a workaround you need to do. So go to data and go to data analyze and single factor, and then select these value. If you select these value, it will not show, because actually the Anova minimum block should be 1. It will give an error. I'll show you what error you will get it, how to rectify it. Yeah. So give OK. And you see here, Anova single factor input range should contain 2 or more blocks, right? So circuit 1 considers 1 block, circuit 2 is considered second block, third block, right? That's what we have seen it in the design of experiment also as well, right? So this is not possible. So what you need to do is, so now I have just converted, let's do workaround in this one. There are 3 circuit, right? Circuit 1, 2, 3, and all these value I have just put it up in column fashion, like this value, and followed by second value and third circuit value, right? Now you will be able to do it. And the thumb rule stands same. We should not select the non-numeric, we should select only numeric. So give OK, and then I'm going to store the result right here, and then give OK. So now we have got it. So, and in this case I'm going to keep it like circuit 1, 2 and 3, right? 3 I'm going to keep, sorry, 1, 2, 3 I'm going to keep it. Okay. And then you also have, like, let's say we also need a standard deviation also as well, right? So square root is a standard deviation, so I'm just going to do it. Okay, so now what we have got the value is, we have got the summary, we have got the Anova. In Anova p value we have got 50.59, right? So let's see, this is the same value we have got, we will be getting in Minitab or not, right? So in Minitab, so all this I have already pasted this value here. So I already pasted this value here, and all we are going to do is we are going to do that stat Anova and then one-way Anova, and in this case we are going to select this factor response is a response time, and factor is a circuit time. 1, 2, 3 circuit we have, right? And we are going to give OK. And this is the interaction, this is the mean, and this is the interaction. We'll come back later. And then you have here exactly the same value you will be getting it. So degree of freedom 2 and adjusted the sum of square, and very importantly p value 50.506, exactly the same value, 100% it is matching, right? We have got the same value as such. And then you also have the other values. So the other value include the simple table. So you also have that 23.4, 28 and 23. So exactly the same thing we have got it here also as well. And then standard deviation 686. 686, you also got it. So we can easily do with the help of this in this Excel itself, right? So I hope you enjoyed this video. Please do like, share, subscribe my channel. You have wonderful day ahead.